All right, here's how we can use the chain rule to find the derivative of a function where the input or where the parameters inside the function are not just h. So it's not just sliding left and right, but whatever's going on in here is actually changing the shape of the function and therefore changing the slope or the derivative. So what we do is we can say here, we have sine of something. So we're going to let u equal 5x cubed. So if u equals 5x cubed, then now we can say that this function is y equals sine u. So we have two new statements here. We have u equaling 5x cubed, which is the input here, and now y equals sine u is our outside function. So our outside function, y equals sine u, our inside function, u equals 5x cubed. Now, in terms of our derivative notation, if we're going to take the derivative of y equals sine u, we're not taking dy dx, we're taking dy d. Oh, see, I say dx, so I write it. We're taking dy du. So how is y changing with respect to u? So as u changes. So it's just a simple way of saying because u is the input and y is the output, we don't want dy dx, we want dy du. And the derivative there would be cosine u. Now we can take the derivative here of u equals 5x cubed. But again, this is not y and x input output. This is an input of x and an output of u. So we want to know how is u changing with respect to x. So how is u changing as x changes? So this is not dy dx, this is du dx. And the derivative here would be 15x squared. Now, why do we care about either of those at all? Because what's really interesting is that if we take dy du and we multiply that by du dx with a little bit of rearranging, since you multiply fractions straight across, we have du times dy over du times dx. And du over du makes 1. So we would just be left with dy dx, which is the original derivative of the original function. So what's that saying is if you want the derivative of a function like this, you can multiply dy du times du dx. So I'm going to multiply, it doesn't matter the order, of course, 15x squared times cosine u. So the derivative of sine here would be equal to this. Now, u is a thing we made up. I said, let u equal blah, blah, blah. U was never in the problem. So I don't really want a u in my answer, but that's okay. I know what u equals. I can just substitute u equals 5x cubed. So therefore, the final solution is that 15 is 15x squared times cosine of 5x cubed. So if j of x equals sine of 5x cubed, then the derivative j prime of x equals 15x squared times cosine 5x cubed. And of course, I can check my work by plugging this function into Desmos, graphing j prime of x, and then typing this equation in on a second line and making sure that they match.